This video is over section 7.1 and it's part 2 of solving systems of linear equations, and it's going to be applications of those systems. Now remember that we're dealing with systems of equations that have two unknowns, and so in order to answer these questions we're going to need to have two equations. The first type of problem we're going to look at is a mixture problem. And here's our example. A chemist working on a flu vaccine needs to mix a 10% sodium iodine solution with a 60% solution to obtain 50 milliliters of a 30% solution. How many milliliters of the 10% and 60% solution should be used? The first thing I'm going to do is define my x's and y's. So I'm going to say that the 10% solution here, I'm going to use x to represent my 10% solution, and I'm going to use y to represent the 60% solution. Now, notice that in total, we're going to have 50 milliliters of solution. So one equation I know right away is that the amount of the x plus the amount of the y should equal 50 milliliters. Now, the next part gets a little bit harder, and that's because we're going to have some of this x solution, this 10% solution, and we're going to look at that percentage because we need to somehow use this 30% of the final solution. We want the final solution to be 30% sodium iodine. So we know that we're going to have some amount of 10% solution, and I'm going to write that as 0.10, and add to it 60% solution, and the y is the amount of the 60% solution. And in total, I'm going to have a 30% solution. But I already know that that total amount is going to be 50 milliliters, so I'm going to do 30% of 50. If I simplify this equation a little bit, I get 0.1x plus 0.6y equals 15. Now I have two equations with two unknowns, and I can solve that system. We have a couple of options on ways to solve, and it's up to you which method you want to use. I'm going to go ahead and use the substitution method, so I'm going to rewrite this first equation as y equals 50 minus x. Now you could also use elimination, whichever method you want. And then I'm going to take the y value and substitute it in for y, because again, I'm using substitution. So 0.1x plus 0.6 times 50 minus x equals 15. And I can't forget to distribute here. Combining some like terms, I'm going to get negative 0.5x equals 15. And I'm sorry, it's negative 15 when I subtract 30 from both sides. So if I divide by negative 0.5, x is going to be 30. So that means I need 30 milliliters of the 10% solution. Now remember, we totaled 50 milliliters, so that leaves me 20 milliliters of the 60% solution, and there will be my final answer. I think the hardest part in this equation is right here where you have to multiply the 30% times the 50. So remember, out of those 50 milliliters, we want it to be a 30% solution of sodium iodine. And that would be a mixture problem. The next example we're going to look at is a motion problem. So let's read the question. When a small airplane flies with the wind, it can travel 450, and this should say miles, not miles per hour, in 3 hours. When the same airplane flies in the opposite direction against the wind, it takes 5 hours to fly the same distance. Find the average velocity of the plane in still air and the average velocity of the plane with the wind. So the first thing is this: we're going to define our variables. Let's say still air x and wind y. Again, we have two things we know. Now, if the plane is flying with the wind, we're going to add its still air and the wind together, and that's what's going to make it go. Now, in 3 hours, if I times this by 3, we're going to get 450 miles. The other equation would be if the plane was going against the wind. So now I'm going to take this still air and I have to subtract the velocity of the wind because I'm not going to have the wind to help me. Now in 5 hours, if I take that speed times 5 hours, I go the same amount, 450. And now we just have to solve this system of equations. I have a few options here. I can distribute the 3 and distribute the 5 and work with them from there. But I'm actually, instead of distributing it in, I'm going to divide both sides by 3 up here and make this equation a little bit easier. X plus y equals 150. I'm going to divide this bottom one by 5 and get rid of that, and then I have x minus y equals 90. The nice thing now with those simplified equations is that I'm set up very nicely to use elimination because I already have the y's that'll be eliminated. So if I add these together, I get 2x equals 240. So x is going to be 120. So that means that the velocity in still air is 120 miles per hour of the plane. Now I can substitute back in and say 120 plus y equals 150. So y is going to be 30. The wind speed is 30 miles per hour. So that's in still air and 30 miles per hour in the wind. Okay, let's take a look at one more example, and this is going to be functions of business. So this is using systems of equations in the business world. A company is planning to manufacture radically different wheelchairs. Fixed cost will be $500,000. So that means that it's going to cost that amount of money no matter how many wheelchairs we make. That's for things like the building and the employees and the machines and things like that. It's going to cost $400 to produce each wheelchair. Now, each wheelchair is going to be sold for $600. The first thing we want to do is write a function of the cost. So what is it going to cost us for X wheelchairs? So we know that it's going to cost us $400 per wheelchair plus $500,000 fixed cost. Now, revenue, we want a function for the revenue per wheelchair. Revenue is how much money we take in. So we're going to say $600 times each wheelchair. Finally, we want the break-even point. And what the break-even point is when is the amount of money we've put out going to equal the amount of money we've taken in? When do we break even? When are these going to be the same? So we're going to go ahead and take those two equations, our cost, and set it equal to our revenue. And we're going to figure out when this is the same. I'm going to subtract 200 from both sides. Or I'm sorry, subtract 400 from both sides. And divide. And we get 2,500. Now, if I plug this back in, I'm going to get 1,500,000. So what this means is that if I sell 2,500 wheelchairs, I'm going to break even. The amount of money I put out, $1,500,000, is going to equal the amount of money I take in, $1,500,000. And so that's what we would call the break-even point. That means for this business to be at all successful, we have to make and sell more than 2,500 wheelchairs. Every wheelchair after that is going to be profit to us. This is where we're going to end today's video. We'll practice these the next time I see you.